Welcome to this topic video on HTTP. What is HTTP? It's a protocol. It's the Hypertext Transfer Protocol. Go visit Wikipedia, a good overall reference. Okay. And actually, the documents themselves standardizing the protocol aren't too bad to read. Okay. And that is the precise definition. Okay. So you don't have to listen to somebody else tell you what it is. You can actually read for it yourself. And the introduction abstract parts of these IETF documents, RFC 7230 and 7231 and related, are actually fairly readable. Okay, so I recommend those. Wikipedia article on proxies, okay, which we'll be using as we develop our software for both servers and when we're doing our front end. So, HTTP. This is how our web pages get transferred from a server to the browser. This is what we call the application layer. We learned about the other layers of the networking stack. The network layer, IP, which gives us worldwide connectivity. The transport control protocol, which allows us to break bigger things like images into smaller pieces and do it reliably. On top of that, we're going to run the Hypertext Transfer Protocol. So what is it? It's a stateless request-response protocol that operates by exchanging messages across a reliable transport or session layer connection. Okay, that's the exact definition from the standards document. So what does that mean? Stateless. The protocol itself doesn't provide any memory about previous requests and responses, meaning each request is new, okay, unless you do something else, okay? And we're going to see what those something else's are so we can remember that a user's logged in and have a session with them and remember their shopping cart or their preferences and things like that. But that is something extra we have to do because the protocol itself provides no memory about the previous request or response. Okay, this simplifies the protocol. Okay, now it's a request response protocol, meaning somebody has to make a request and somebody's going to give a response. Okay, all exchanges are initiated from the client by making a request. And we're going to keep this real simple, okay? There's plenty to get complicated, but it's a request and a response. Servers cannot independently send updates to the clients, okay? A server must wait to hear a request, then will deliver a response. If you want something different, where servers can independently send updates to the clients, there are other mechanisms. If you want a very robust and real-time mechanism, WebSockets is what you want to use for that. Okay, that's how you can make nice two-way chat things. Okay, but we're not talking about that. We're talking about HTTP, different protocol from WebSockets. It's a request and response. You don't get something back from the server unless you ask for it. Okay. I said messages. How's a message different from a packet? A message is an application layer packet. Okay, it's a block of data stuff. Okay, but it's an application, meaning it's concerned about what's happening between the browser and the server, not the network layers underneath. Okay, large HTTP messages are broken down into smaller packets by the transport layer, which is usually TCP. But some vendors have other protocols that can be used, okay, and then sent over IP, okay. So we have HTTP, application messages are broken down into smaller pieces by the transport layer, TCP, and then sent over the World Wide Web or the internet using IP. There are only two types of messages, Okay? We're going to hear about all sorts of different things with HTTP, but there's only two basic messages. Only two messages, period. Request and response. Okay? The messages are passed in a similar format to that used by good old-fashioned internet mail, which you've probably never seen that form directly. Why would you? Okay? Because we all get our mail through mail clients or web clients and such like that. So we actually never see the actual textual format. Okay. The client. Who's a client? The client is any program that makes a connection to a server and makes requests. If you're making a request, you're a client. Okay. At least from that perspective. Okay. The server. A server is one that accepts connections in order to service HTTP requests from clients by sending responses. Okay, we said two messages, request and response. Clients make requests and create request messages. Okay, servers create responses. Okay, what's the most common client we're used to? Our browser. It's sitting on our computer, okay, makes requests to a server, okay. Now, the same computer can host multiple clients and servers, okay. We're going to use this all the time in development because we will write servers, maybe run multiple servers on our machines, our laptops, and we will make requests to those servers from our browser or from other programs we write. Okay, so we can actually write programs with code rather than a browser to make requests. We'll use that for testing and other purposes. Okay. In addition, a single program can have both client and server functionality. Okay. Okay. Typical clients and servers. Web browser is our client. That's our okay. But we can and will make requests programmatically, okay? Web servers come in many different flavors, depending on deployment, context, features, and performance, okay? The web servers we are going to be writing in our class, okay, are used throughout the net, but they usually sit behind another server, okay? Because they're not intended to be just left out there hanging on the internet. They usually sit behind another server. Okay. When you do something like that, you're dealing with something called a proxy, an intermediate system, okay, called a proxy that takes part and receives requests, okay, and forwards them on, okay, and then receives responses and forwards them on. Okay, so we're going to learn about those in a little bit. Okay, there are multiple HTTP flavors out there, and not on this slide is HTTP 3, which is just coming out. Okay, HTTP 1.1 is a text-based protocol that uses carriage returns and line feeds. Yes, seriously, it's text-based to separate various parts of the messages. Okay, HTTP 2 keeps most of the high-end interfaces we will learn, but provides much more efficient methods for encoding the binary and transmissions of messages. Okay, both flavors are supported by Node.js and Express.js, and we will only use HTTP 1.1 for simplicity. However, everything you're going to learn here can apply to that from the point of view of us writing servers. Okay, because we're not going to get into too many configuration details on servers. So, what do these HTTP requests look like? Message format. Okay, this is HTTP 1.1. It begins with a request line that includes a method. Okay, don't get the method confused with the fact that we have just two types of messages, a request message and a response message. Okay, this is a method. This is kind of basically saying, what do I want the server to do for me? Okay, this is sitting within a request message. Okay, this is part of how do I ask the server what I want to do. Okay, so we give it a method, uniform resource locator, URL or URI is the general term for a URL. Okay, followed by header fields, which contain a bunch of things that qualify the requests. They have client information. They have metadata saying the encoding and things like that. There are a lot of different header fields that can get very complex, but we don't need to worry about those all now. And you dig into them as you need them. They are important, but you don't need to memorize them or anything like that. Okay. Then, yes, they actually use an empty line to indicate the end of the header section, and you can actually have a message body containing payload, if any. Requests may contain a body. They don't have to. Depends what you're trying to do. Okay. So what does this look like? What are the method types? Get, head, post, put, delete. Okay. Each of these things has a definition. We'll be using gets a lot to go get resources. Later, when we work with forms and things like that, and we're working on the server side, we'll use post, put, and delete. Head we'll use in testing because it just asks if the resource is there, but it doesn't actually tell the server to send the whole resource. It just makes a request, and it's good for checking things. Okay. Connect and options and trace we will not be using in this class. Okay. The request target is either the entire URL, URI, or just the path part, okay, of the URL. Why just the path part? Because we have other ways. The domain part gets translated into an IP address, okay, typically. So we sometimes don't have that in there. Okay. Header formats. Okay, what do they look like? We have a bunch of different headers. They'll have a header name, they'll have a colon, then they'll have information, then carriage return and line feed. Okay. So what kind of headers are there? Things that tell you about the host, about caching, what kind of stuff you will accept, what kind of care sets you'll accept, things about authorization. So you can see security gets involved here. And various things about you, information like user agent. Okay, what kind of browser are you using? So you can see there's privacy and security concerns that come in with the use of the headers. Okay, another time we'll discuss those. Okay, what's an example? Let's look at a request to my web page because it's simple and easy and nothing too complicated. A single website, nothing complicated going on here. Let's see, get / the protocol, first line feed, the host information, okay, about who we're trying to talk to, connection information, blah, 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 user agent, Mozilla, so that's a Firefox browser, okay, what kind of stuff will we accept, HTML, blah, 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 okay. Now, you can see this stuff live, or you can capture this stuff live using a protocol analyzer, such as the open source Wireshark protocol. Okay, so let's take a look here. I captured HTTP traces from me starting to make a request to that home page you saw on the slides to receiving it. Okay. We see Ethernet, Internet, IP protocol, Internet protocol, transmission control protocol, and HTTP. Those are all get involved in this single request message that goes out. Okay, why? Because these all are needed to carry the HTTP message. Okay, so here we can see this information. So this is the first line. Okay, the request line, get / which is the path portion, HTTP, the host portion contains the full name in here, okay? And we see all these other pieces, okay? This gets carried over the transmission control protocol. And we learned that the well-known port that we don't have to put in our URL is 80 for HTTP and 443 for HTTPS. And the only reason I remember that is because I've been staring at it too long lately. Okay, so we need the transmission control protocol to carry our messages. Transmission control protocol goes within an IP packet. Okay, here's my router's source address. Okay, no, that's actually my computer's address. And this is the destination address. This is a private IP address sitting within my home. Okay, not routable. And this is the destination address of GrottoNetworking.com. The IP packet goes over Wi-Fi Ethernet. Okay, the destination is, oh yeah, that's right. Ethernet addresses, which is shown here, is given out by the IEEE, the manufacturers, who then put them in their equipment. We each get a unique one. So we can tell, and Wireshark knows, that my access, my wireless router, is a TP-Link router. And that my computer is an Intel-based Ethernet controller. Okay? So we can see the full stack here. Okay? So that's a request. Okay? Once again, we're not going to have to worry about all these headers. Okay? So don't panic about that. Okay? The clients and servers we'll use take care of most of the headers for us. Okay, that's important because when it comes to security things and like that, okay, it's best not to have us putzing and making mistakes ourselves. Okay, we're going to add a few headers, okay, for various purposes, but usually with the help of a library that's designed to help us do that. Okay, like secure sessions for logins and such like that. So what does the response look like? Okay, remember, 2 message types, request, response. In the request message, we can have lots of different methods like get or post, whether we're just asking for something or we're submitting a form. Separate thing. It's still just request and response are the fundamental message types. Okay. The response message begins with a status code, okay? The famous 404, not found, okay? Success 200, or an error code like 404, and a text phase, okay? Possibly followed by header fields containing information about the server, the resource metadata, representation stuff, okay? An empty line to indicate the end of the header section. This is HTTP 1.1, it's text-based. Okay, that would not be true of HTTP 2. And finally, a message body. Okay, so as far as we care in the programming we're going to do, we care that we get a status code back, we get headers, and we get a body. We're not going to have to worry about the exact format. Okay, protocol things to handle the HTTP protocol will deal really with the differences between HTTP 1.1, HTTP 2, and possibly HTTP 3. Okay, so the response start line. Okay, you get a reminder of what version you're using. You'll get a status code and a reason. Okay, the codes go between 100 and 505 last time I looked. Okay. Popular status codes, 200's okay. 400, bad request. 401, unauthorized. 403, forbidden. The famous 404, not found. You're asking for something that doesn't exist. And one that'll may be kind of new to you, but you'll definitely see it as we're going to write our servers, is 500. Internal server error. Okay, so it's a problem with the server code. Not a problem with the request, but you crashed the server. Okay. Response headers, age, cache control, expires, date, location, e-tag, class modified, blah, 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 blah. Okay. Information about the server over here. Okay. We're going to see these things. You don't have to worry about all these things. Okay. And we got stuff, metadata about content type, encoding, and things like that. Our server frameworks are going to help us work with these. Okay. Unless you're writing a low-level server framework yourself, okay, you won't have to deal with those. Okay. Example response. Okay. What does it look like? Let's look at it in the packet trace. Okay. So the first thing that went out was a get. Okay. And that went from my computer, here, the source, to this external destination. Close. I didn't want to bring that up. Now, the next thing that came in is going to be a response. Okay. And it came from the external host. Okay. So let's look at this. Oh, look at this. Look, it's just like the format we said. It repeats and says, hey, I'm HTTP 1.1, 200, hey, everything's okay. Then it starts giving me header fields. It tells me the server is an Nginx server. It tells me the date this was done. Sorry, this is old, but we can do it again, but not today. Okay, content type is text, HTML. Transfer encoding, whatever that means, don't sweat it. Connections, all sorts of different things. Okay. Chunked response, blah, blah, blah. It tells us about that stuff. Then finally, oh, what's this? Line-based text data. Whoa, that's the actual web page from my website. Okay, it's starting to be sent. Oh, wow, really? Yeah. What else is going to be sent? Well, that's just the start. Once this comes back, oh, let's go look at the picture first. Then we'll take a look, okay? Example response, okay? Now, that's not all there is to it. We just got the page back, okay? The web, wherever it is, the browser here, just made the request for the page. Then, once it gets the page back, it starts to read it. Then it starts asking for all the resources on the page. Okay, so let's see that live or recorded. Okay, so we get back the page. Okay, and we're seeing the page here in the response. What's the first thing we hit in the page? I see we're going through the head here, blah, 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 blah. Link. Oh, it wants some CSS file. Oh, the next thing our browser does is request that CSS file. Okay, then, oh, look here, there's another CSS file, Grotto CSS. Oh, it makes a request for that. Okay, next thing it sees, blah, 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 blah. It sees stuff about scripts and things like that, and weird hidden things. We see that it goes and requests jQuery. This is an old site, and trying to be very compatible. It requests Bootstrap, a Bootstrap library. Then we see it starts asking for the images. Okay, so it asks for all of these different things. Okay, it asks for favorite icon, fave icon, which I don't have on my site. Okay, so it's not found for that. Okay, so that's the anatomy of that request. Okay. Okay. So a request comes in, and then the response comes in. Then the browser looks at the page and starts requesting the additional resources. Hence, to get a page, a full, complete web page, actually requires many requests and many responses. Okay. Each image, each CSS file, each JavaScript file, separate requests, okay, and a separate response. So when something goes wrong, we can see this, okay. Now, how do we see this stuff? Okay. Our developer tool panel has a network panel, okay, to show off stuff. There's one important thing if you're doing a lot of debugging is there's this switch here to disable the cache. If you want to get a fresh download, okay, because browsers try and be very efficient and save information that doesn't change too much, like CSS files and stuff like that. If you want to make sure you download everything fresh to see it happen, in your developer tools, hit disable cache. But look, we can see the same thing I showed you in my packet trace. We can see the various requests coming from the server. Each request is accompanied by a response, okay? So we're not going to see all the TCP, IP, and lower layer stuff, okay? The browser doesn't work with that. The browser works with HTTP. But when it comes to inspecting browser information, the request headers, the response headers, the information sent, etc. Okay, here's the raw information that came back, right? You don't see at this point, there's no styling or anything like that because it's the web page before the CSS came back. Here's the CSS coming back, okay? So we can inspect things, okay? HTTP requests here, and the responses, corresponding responses, all nicely done for us, okay, by the browser, okay, because this is going to be important for debugging, okay, and understanding what's going on. So we see all the requests that go out, and for each request, the browser will show us the particular response, okay, response payload, okay, preview, etc., okay. Now I said sometimes we use other things, or other things get in between us and the server. These things are known as proxies, and they come in all shapes, flavors, and sizes, okay? The definition from the IETF, which is the most general, is an intermediary program which acts as both a server and a client for the purpose of making requests on behalf of other clients, okay? So here's a client, here's the eventual server. Instead of talking directly to the server, we go through a proxy. He will do things, he or she, it, will do things with the request before forwarding it on, just like it will do things with the response before forwarding it back to the client. Why would we ever do this? There's a lot of reasons to do this. Some good, some bad. A forward proxy, okay, and there's more than just these two types of proxies, okay? Right on the next page, I'm going to show you a third type, okay? So this isn't all there is, but there's these two general classes, okay, that it's good to know about. A forward proxy is one that goes from you facing the internet, okay? It's used to receive data from a wide range of sources, okay? It can be used for monitoring, content filtering, bypassing filters and censorship, or caching. So it can be very worthwhile, okay? For example, caching. If there's a popular website or a popular movie, okay, off Netflix or Amazon Prime or a YouTube video, that will generally be cached somewhere closer to you than where it originally came from. This is to save bandwidth across the internet, okay? So when a request comes for that video, okay, it will hit something known as a content delivery network or whatever you want to call it that acts as a proxy. It sees that request and says, oh, I can service that thing better, okay? I'm going to grab that locally and return it, okay? Censorship. Unfortunately, proxies are used for censorship, both good and bad, in the sense of protecting your children from nasty websites, protecting you from sites that are known to have malware, or trying to inhibit free speech in the bad sense. Okay? So, and also used for monitoring. This is why if you're in a workplace, you never go visit sites that are questionable, okay, or just non-work related sites, because if you're at a work, they're always going to be monitoring, especially for security purposes, to make sure that malware isn't coming through, so that almost everything you do will go through a proxy in and out. Okay, so that's one type of proxy that you've been using without realizing, especially the caching. Okay, you don't realize it, but it's making your life faster and more wonderful. Okay, and they come under names such as content delivery networks, but the idea is proxying and caching. Reverse proxy is something else entirely. Okay, this is a proxy that serves as a front end. Okay, this is what's sitting there conceptually in front of the data center, servicing requests. Okay, when you call to Google, when you call to Facebook, when you call Wikipedia, whoever, any big site, okay, the first thing you're going to hit is something that acts as a reverse proxy. Why? Because one computer cannot handle all the requests coming in. Okay? So what the first thing they're going to do is receive the request and farm it out to other machines. Okay? Okay? It's a front end used to control access to servers which are within the data center or on a private network and things like that. Okay? Common tasks, famous tasks, are load balancing, authentication, decryption, or even caching. Okay? We're going to have yet another reason for doing this is we're going to use this as part of our deployment, a process for our Node.js servers. We're going to put them behind a big internet-facing server like Apache 2 or Nginx, and we're going to actually have those serve as a reverse proxy to our Node.js-based servers. Okay, why do that, Professor? Because Apache and Nginx are good and hardened for facing the internet in general. Okay, so a lot of times you'll put other servers behind servers. Reverse proxy is what you're doing as soon as you have a situation like that. The professor, yes, you said we're going to need one in development, and yes, we will. To keep our development simple and avoid having us to deal with too much with CORS, cross-origin requests, I forgot what the S stands for, cross-origin requests and things like that, we have to deal with security configurations and such like that. We are going to use a development server and combine that with a proxy. Okay, why? Because we're going to be making front-end apps that need a development server. At the same time, we're going to have our application server, and we want to test both of those running on our machine. Okay, so when we run our browser, we're going to go get our front-end app from our development server, but then the app is going to make requests all the way over to the application server. To handle this nicely, we're going to need a proxy that has some requests go to the development server and forwards others to the application server. Okay, yet another use for proxies. Okay, and we'll get to that. Okay, so the idea here when we're dealing with proxies and many of these things, we can think of it as application switching. Okay, because we use the URL or portions of URL to send stuff to different places. Okay, we can use the HTTP method too. Okay, we will be writing code that will do exactly that. It will look at the method and portion of the URL and call different functions. Send the request to a different function to be handled. Okay, high-end servers provide, such as Nginx and Apache, provide elaborate configuration mechanisms to do this, okay? We're going to be doing this a bit within our own programs, okay? So there you go. A quick overview of HTTP, and we're going to get using it real fast.